Okay, this is Thanksgiving 2013, November 30th. What we have going on here is the tube RF amplifier circuit, which is fed with the BK. Can you see that here? There it is, almost. It's the BK 4040B 20 megahertz function generator. We're doing 13.56 megs, 2 volts. In fact, we'll bring the voltage down here, the input. We can bring that down to 0.7, which is about what a crystal will oscillate at when it's going. And we'll turn that back up a little bit here. We got a variac that feeds an isolation transformer, and we have adjustable voltage out, 115 out or 220 out, and that goes into a RF filtered rectifier. We got chokes in here and capacitors to keep it clean. What happened to our voltage here? We had, I guess I'm going to have to turn that voltage back up on the output here. See if we can get that. There we go. We had to do about 1.6 volts to get the output to register on here. This is the breadboard. This actually, breadboard is made out of a plastic top for a liquor case. You put about, what is that, 1, 2, 3, 4, 5 bottles of liquor in here. Our neighbor happens to be owns a liquor store, and he gave us a case of this for Christmas one day. So anyhow, the waveform from the function generator comes into a BNC connector here. So this is a coax. So we got the casing is grounded. The casing output is also grounded on the output going to the scope. This is a Radio Shack breadboard. And we got each one of these 6 tubes. In fact, this is a 6L6. This is a 12X or 12AX7. They use these on the guitar amplifiers. Very famous tube. People love those tubes. It's a dual triode. The rest of these are 6CL6s. These are used in television sets from the old days. You can still get new old stock, and these are the EL84s. These are also produced brand new today for guitar amplifiers. It's an output tube. So we're experimenting with setting the biases. We've got potentiometers to adjust some of the biases and stuff. We've had a problem with overloading the bias, these pots, and burning them a little bit, so gotta be careful. We've got some high wattage, about 5 watt resistors to adjust the bias, because we've got max going into the 6L6, and then we drop it down. Here's the voltmeter here. We're running about 360 volts in. Then we have to drop it down to about 250 for some of these other tubes, so we've got to run some big wattage diodes in here, or resistors. Power switches for the 3 filament transformers. So you've got number 2, 3, number 1 over here, so we can control the filaments, turning them on and off, and each transformer powers up 2 tubes. Line filter, we filter the voltage coming from the wall for the transformers, so we don't get any feedback into the wall. And the same thing here with the RF filtered rectifier for the plate supply. It's got chokes inside there. It's got, let's see, 3 chokes. One for the DC for 60 cycles, and it's got a 2 other ones for the RF. In fact, let me see that. Let's try and find that schematic. We'll share that with you guys. Here we go. This is for the RF filter we've got here. Got a differential filter right here. the two RF filters here. This is the DC filter. So we've got the power coming in, full bridge, bleed resistor, a couple capacitors here, another big one over here. That's some of the values. C1 and C2, these are both 250, so we got 500 volts across here, and then the big C3 is 475 at 450. And the big, this is the DC choke here. It's a C2685 at 2 amps. You can get that at Allied. The other radio frequency choke, 14 turns on a 1-inch torrid. And resonant frequency, that was about 12 to 15 megs. So 320 volts AC in, and we're getting about 420 DC out max. That's the max we want to put in there for the capacitors. The other radio frequency choke right here, that was a CM881U-9A. And number C4, the RF capacitor, we got an RF capacitor down here that was about 0.01, 500. So any RF noise coming back from the tubes, it's going to hit here first. It's going to ground that. This is going to earth ground here, and then it's going to hit the RF chokes. So there you have it.